One concept to prevent us from taking away our own lives and keep surviving is the badness of death, which means that life is better than death and death is worse than life. There are bad things in death itself. When talking about badness of death with reference to life, we need to be clear about what life is. What are the characteristics contrasting life and death? There are roughly two big schools of thought to approach this problem: reductionism and non-reductionism. Reductionism means life can be reduced to much simpler factors, whereas non-reductionism suggests otherwise. Because non-reductionism is basically saying that me is me, life is life, which does not consist of simpler factors. It's not very helpful for defining one's life. In addition, one common interpretation is that the nature of one's life is the immaterial, non-physical soul. Again, it's hard, if not impossible, to define soul, let alone to observe, detect, or prove it. Non-reductionism therefore leaves very limited room for discussion. It's basically just I feel it. Modern philosophers therefore adopt reductionism and propose three criteria determining the continuation of life: psychological continuation, continuation of capacity for consciousness, and physical continuation. But these criteria all do not completely agree with the commonsensical view. Therefore, I think that I should revise how I interpret life and death and propose my own interpretation. Okay. First, psychological continuation. It's all your memory, cognition, personality, etc. If you continue to live, you keep your memory, cognition, and personality. If psychological continuation is the only criterion, philosophers think that your replica with exactly the same psychological state is the same as you, and it doesn't matter whether the original you gets destroyed. The reason that if people don't agree that they survive with the replica after being destroyed, psychological continuation is not enough for defining survival. The reason people don't accept that the replica is themselves may be that the replica does not share the same consciousness. So now consciousness is an important factor. Since people lose consciousness during sleep regularly, strict continuation of consciousness should not be considered as a criterion of survival. Philosophers instead propose that life is different from death, as life keeps the continuation of capacity for consciousness. Even though you lose consciousness for a period of time, you regain it again. However, the continuation of capacity is very ambiguous and unhelpful in this case. After all, the loss of consciousness is because of the loss of capacity for consciousness in that particular state of the brain or neural circuitry. The switch is off, so the current state of the circuit has no capacity for conductivity. As both psychological continuation and the continuation of capacity for consciousness do not work well to differentiate life and death, philosophers then propose another criterion: physical continuation. focusing on the machinery generating consciousness, which is the brain. The brain holds your psychology and generates consciousness from time to time. As long as the machinery is still present and the switch can be turned on again, life will continue. Even though you are under sleep, in a coma, suffering from memory loss, mental illnesses, etc., as long as it is possible that your brain can generate consciousness again, you are considered alive despite any psychological changes and illnesses. On the other hand, the replica does not make you happily accept your own destruction because it doesn't have your exact brain but only a replica. Now, this proposal requires that your brain needs to be here for you to survive and address both changes in psychology and consciousness. It looks great, right? But identity problem steps in as our brain changes and exchanges materials constantly. If people accept that physical continuation allows the particles in the brain to be changed and eventually the whole brain will consist of completely different particles, then why is replacing the brain with the replica not considered as continuing to live? Furthermore, what if we do not replace the brain in one step, but a lot of steps gradually imitating normal physiological processes? And what if you sustain brain injury or surgery from which parts of your brain are suddenly changed, injured, or removed? This scenario is likely accompanied by sudden psychological changes and changes in consciousness. Are you still considered living? If yes, change is acceptable. Another scenario is that a patient suffers from a disease where neurons lie and particles are lost from the brain. The doctor collects and saves all the particles lost from the brain and reconstructs the brain cells, cultures them, and reconstructs the brain. During the culture and reconstruction of the brain, old particles are lost and new particles are introduced as wastes are removed and nutrients are provided. Finally, the doctor treats the condition and puts the reconstructed brain back. Has this patient died? If not, the brain can even disintegrate for the consideration of life. Let's go back to the central question, how life differs from death. If I admit that the subjects from all the above scenarios live, life involves the physical continuation of the particles from a brain that can be changed, reformed, or remade. And it is not much different from death. After all, particles are recycled after death. It is possible that the particles once from your brain are now in others' brains. Life and death are therefore one and the same. It is just about the circulation of materials between conscious subjects. If I hold questions to some of the scenarios above, I propose that one solution may be to add the rate and magnitude of changes in the physical brain, psychological state, and conscious state in the consideration and compute a survival index, which is inversely proportional to the rate and magnitude of changes in the physical brain, psychological state, and conscious state. People can use this to evaluate the change of survivingness under different circumstances with reference to wakefulness. Wakefulness is assigned here as the reference because consciousness and survival in this state are supposed to be present and rather stable. For an ordinary situation where the subject does daily activities, the rate and magnitude of changes are relatively small within physiological limits. The survival index will approach infinity. For biological death, the changes are drastic. Brain physiology stops. Psychology and consciousness are lost. The survival index will approach 0. The subject is considered dead when compared to the ordinary reference situation. For sleep, the brain gradually goes into the sleep state where the conscious state shifts along the sleep cycle. Although the conscious state changes more than that during the ordinary situation of daily activities, changes in both physical brain and psychology are still relatively small within physiological limits. The survival index may be slightly lower than the ordinary situation, but still high. For brain injury, surgery, or coma, the changes will be more sudden and may even be present in all physical, psychological, and conscious aspects. The survival index will be even lower. However, after recovery, compared to the ordinary situation before the incidents, the changes may not be so big, so at this moment, the survival index may go back or even approach infinity again. For circulation of particles among other individuals, the particles of the subject are now slowly involved physically, psychologically, and in the conscious aspect of other individuals. The physical brain integrates and changes into a lot of different things. Some of the particles may be involved in others' brains. Although the results are not nothingness, the change is drastic. The survival index is expected to be extremely low. One more common interesting scenario to me is growth and development. Because the survival index is a relative measure depending on the reference point, we can set the reference point at a newborn baby and ask the survival index at the age of 30. Although compared to a newborn, a 30-year-old is quite different. The rate of change is still within physiological limits, though because the rate of change during growth and development is higher than that in the ordinary situation, the survival index may be slightly lower. The above discussion is interesting as it turns out that life and death may not be that clear-cut, but with gray areas. The lower survival index in the growth and development scenario suggests that I, to a certain extent, agree with some popular saying that the past me was dead. And it makes perfect sense, as death is just a change of state after all. However, I need to point out that the survival index is still a very primitive idea, as the detailed calculation is not worked out. How the changes are quantified is not specified, but greatly affects the interpretation. For example, if changing to nothingness is considered as a greater change than changing to a different thing, the case of particles circulating in others' brains after the biological death of the subject may have a slightly higher survival index than the case of immediately after biological death. This can be interpreted as parts of you living in others after your biological death. Moreover, additional factors or variables might also need to be considered, but I hope this serves as a theoretical background for the analysis of life and death problems.